All right, we're going to look at a special case, and we're going to go more in depth in this in our next chapter, but wanted to point out how it relates to similar triangles in this chapter. So I have gone through and highlighted or colored the angles so that we can kind of see what angle corresponds with what angle. And I've also gone and separated out these triangles so that we can see the three triangles that are present here. It may help you, some people it helps if you want to flip this triangle around so that it looks similar to this triangle. Some people find that helpful also. But if you look here, you can see that we have a right angle here, and those are our right angles there, as well as we have a right angle here. So you can see that in any of our similarities up here, that this angle S is going to correspond with Y and Y. So see how there's an S there, a Y to start, and a Y to start. Okay. If we look at our other angles, we have the angle R here, and we have the angle R here, and angle R here. So those are marked off in red. And then the angle T here, and the other angle T here, and the other angle T here. So when we look at our similarities here, we can see that if we start with this large triangle, which was given to us as SRT, that it is going to be similar. I started with the 90-degree angle, went to the red angle, and ended at the green angle. That I'm going to start here and go from the 90-degree angle to the red angle and then to the green angle. So if those coloring helps you, then go ahead and do that. Same thing here. I'm going to start at the 90-degree angle. I'm going to go to the red, and I'm going to end at the green. And then that's going to help us be able to set up our proportions. So I'm looking at from the small to the larger one here, and I'm actually, other than we know that this is where X is located here, not really using this triangle here. So I'm going to say that if I look at SR, which would be, if I would look at this measure of 13 here, which would be SR right there, that's actually in proportion to RT. So that's how I knew SR to RT. And so that's how I have this first one, 13 over X plus 12. And then when I look at the next part here, this is 12. And that is RY, so right there, RY, and that should be in proportion to SR. And so that's how I knew that this was going to be 12 and this was going to be 13. So I'm going to have 12 to 13. After that, it's just a cross multiply and then solve the equation. End up with 25 over 12, which is approximately 2.1. All right, if we look at our next problem, we could see that we are given that this is 5 and this is 100, so this whole thing would be 105. And if we think about our similarities, if we look at the larger triangle, LSR, compared to the smaller triangle, they have angle L that is congruent to itself, obviously, and then they have a right angle here in S and a right angle here in A, and so that tells us that these would be similar by angle. And so if this is LSR, then this will be LAE. Okay. From that, we could use that to set up our proportion. That if we look at the large triangle here, 105, to that smaller part, 100, That should be in proportion now. And then the larger part here, x to 17. And if we go ahead and cross multiply and divide, we could see that our answer is 17.85. If we look at our next problem, we have the Willis Tower, which is formerly known as the Sears Tower, and it says that on any particular day, it casts a shadow of 100 feet 11 inches. And so there's that 100 feet 11 inches. That because we're going to have other inches in the problem, we're going to go ahead and just turn that measurement into inches. Then we have a person standing here, 6 foot tall person. That's to be 72 inches. And they're casting a shadow of 5 inches. And so we are wanting to know, well, how tall is this building? And that's our x. And so you can see we can set up our proportion that x is proportionate to 72. And then that the shadow of the building to the shadow of the person is this over here. If we cross multiply and divide, the first answer that I have here is in inches. And then if need be, we can convert that answer to feet if we need it in feet. All right, the next type of measurement we're going to look at is indirect measurement using mirrors. So we're going to look at, it says we're back at the Willis Tower. It says Wendy draws an X, so right here, on a mirror and places it on the ground 115 feet from the base of the Willis Tower. So I took that 115 and I converted it into inches because we're going to have to convert to similar measurements, so I just started that now. She stands so the mirror is between her and the tower. When she looks at the mirror, she can see the top of the building is reflected in the X. If Wendy is standing 5 inches from the X, so here we go, standing 5 inches, and her height, we look at the height as for the height from the ground to her eyes, is 5'3", which is 63 inches. So we're looking at approximately how tall is the Willis Tower. And so we can look at what we've set up here is 63, so the height of the person measuring to their eyes in proportion to the distance from the mirror. And then over here, the height of the object in proportion to the distance from the mirror to the building. And you can see we just cross multiply and divide, and that this is our answer in inches, and this is our answer in feet. And so those are the two types of measurement they're going to be looking at, the direct measurement and the indirect measurement.